Hi friends, welcome to my channel. Today in this video we are going to see how you can configure IPsec VPN using certificate X509 instead of pre-shared key. Well, there are plenty of firewalls in the market which allows you to have both kind of information with the IPsec configuration, which means you can use pre-shared key along with the certificate as well. But then today we are going to test the certificate-based configuration with the open source PfSense firewall. So let's get started. Before getting into the configuration, let's cover the theory part. So in normal VPN, in phase one, you will have 6 packet exchange. First two packet exchange will be, the endpoints will try to negotiate the uh, proposal, or the firewalls involved will try to negotiate the proposal, and then the third packet and the fourth packet, each end will tell that this is the th public key that I'm using along with the hash, which is used for the computation of key after the 4 packet exchange. And after this 4 packet exchange, you will have fifth packet, sixth packet encrypted in main mode with the help of the keys that you have just generated after 4 packet exchange. So the fifth and the sixth packet will contain the ID payload, which is the identification payload, and hash payload. So the first 2 packet will contain the proposal. The first packet you will tell the other end that these are the proposals that I'm supporting. The other end will tell you that um, he will choose one of the proposal and he will send the selected transform set. So in the third packet, if I am initiator, I'm going to tell that this is my DH public key, and along with that, I'm going to send him the nonce. And nonce is the keying material. It's a random value generated for the liveliness, and it is again a keying material as well. So to be very precise, I have noted down everything. Um, okay. So the first packet will contain the proposal. Second packet will be having the selected proposal by the responder, and the third packet will, okay, this is, okay, this is a pre-shared key technique used here. Okay. So the first 2 packet exchange, you will decide what are the cipher suite that you are going to use for the IPsec, and then third and the fourth packet you will tell. So this and the initiator will tell the responder that this is the th public key that he is using along with the nonce, which is the keying material, as well as used for the liveliness check. After this, after 4 packet exchange, you will try to calculate the keys on each end, and then fifth and the sixth packet will be encrypted. So this is, in the fifth packet, you will have ID payload and hash payload. You can ignore this for a normal IPsec VPN using pre-shared key. So you will have ID payload and hash payload. So the ID payload will by default be the public IP that you're using on each end. For example, in my case, firewall PfSense 01, PfSense 02. Okay, so PfSense 01 will put this information 192.168.0.109, which is a peer IP, in the ID payload along with the port number, and the other end is going to do the same thing. It is going to put the peer IP his own peer IP 192.168.0.129 along with the port, so that this end can actually identify the other end. And by default, it is going to be the peer IP. But if you want, you can change this to any FQDN, host name, etc. So by default, it is going to be the peer IP in this field and the hash payload. So if you are using IPsec VPN with certificate, then in the proposal, you will tell the other end that you are going to use RSA signature for the authentication instead of pre-shared key. And once you have negotiated the RSA algorithm, which is going to be either RSA, DSA, or whatever, the same thing you're going to use to understand the signature and decrypt the signature. So the only difference that you will see when you're using certificate based authentication in IPsec is that the fifth packet will have the ID payload as usual, on the basis of the configuration that you have done. By default, it is going to be the IP address of peer. Else, it is going to be the configuration that you have done, like the FQDN or hostname, etc. And then you will have the cert payload, which will contain the certificate of each end, who is presenting his authenticity in terms of certificate, in terms of the information fed into the certificate. And then it is going to have a signature payload. Well, the algorithm that you have negotiated during the first two packet exchange, the same algorithm will be used for the encryption of the signature. Well, the signature is generated from the hash. Okay, and there is a specific formula for that. I'm not going into depth. So the signature value is actually generated from the hash, which in normal IPsec VPN is a normal payload that goes with the fifth and the sixth packet, ID payload and hash payload. So there is a formula to calculate the hash. So just keep it in your mind that you are going to have an ID payload and the certificate payload, which will contain the certificate information and then the signature. The signature is generated from the hash value. Okay, and you're going to encrypt this signature with the algorithm that you have negotiated in the first two packet. So this is the difference that you are going to see if you're using a certificate instead of pre-shared key. And let me check whether I have the formula for the calculation of signature. So you can see here, signature is generated from the hash value, and this hash value is a normal payload when you're using pre-shared key. Okay, so you can see how hash is generated. I'm not going to cover this in this video. If you people want me to cover the generation of keys in IPsec when you're using different authentication mechanism, then I can cover that. Please leave your request in the comment section. But just keep this thing in your mind that if you're using certificate, then you're going to have a cert payload and the signature payload in the fifth and the sixth packet, which is encrypted by the keys generated after 4 packet exchange. Plus, this signature payload will then be encrypted by the negotiated algorithm in your first 2 packet exchange. And now we will get back to our configuration. So this is PfSense Firewall 1. The VPN configuration, well, for that you'll have to go to VPN IPsec. I already have this configuration, so it's very simple. Let me show you the configuration. So you can see here tunnel, IKE version 1, IPv4. The interface that I'm going to use is EX0, which is having the IP address 192.168.0.109. The remote IP is this. This guy is peer IP. And then I've given a description as IPsec. And in the authentication method here, I have given as mutual certificate. Okay. So if you have a certificate exported as PKCS 11, which is basically the bundle of certificate and the key in a file, then you can choose this information. You can choose this option, as you can click on this option, mutual certificate, and there is no option of using the pre-shared key along with the certificate in this particular open source version of firewall. So there are some firewall which will allow you to use both, and I will cover that when I am implementing the same on the Juniper firewall. So today we are going to see only for the certificate, no pre-shared key. And then the negotiating board as main. Identifier, well, this is the ID payload that I was talking about in the fifth and the sixth packet. So by default, it is going to be the IP address. And what is the IP address it is going to have? This guy will have 109. This guy will have 129. And if you want, you can change this to any value listed here. And most of the firewalls will have these information like the IP address, distinguished name, UFQDN, and dynamic DNS, whatever. So I'm not going to change that. I'm going to keep it as default. Peer identifier, IP address. I'm expecting the peer IP, which is I'm expecting the peer firewall, which is this guy, to send this in the ID payload. For example, I have taken a capture where I have tried decapsulating the negotiation. This is a normal IPsec VPN with pre-shared key. So if we go to the fifth packet, you can see here that it is encrypted data, but since I have exported the key and the cookie value, so I'm able to decrypt this. And you can see here identification payload, and if you expand this, it is going to show you the IP address. So this is the identification payload by default and the hash payload by default. This is the hash data. And in certificate based IPsec VPN, you're going to see this payload, and you're going to see a signature payload and a cert payload. And signature payload is actually generated from this particular information. The signature is generated from the hash data. So this payload you will not see there. So let's close this. Okay. So peer identifier, peer IP, and my certificate. Select the certificate that you're going to use. I'm going to cover the certificate in deep in some time after this configuration. Okay. So you will have to select the certificate that you generated for this particular firewall, and then you will have to export the CA which was used for the signing of the certificate, which means the PfSense 01 certificate was signed by CA. So I have exported both the certificates, the CA cert as well as the server cert that I'm going to use on the firewall. And then encryption AES 128 SHA-256 DH14, re-authentication time 288800. Nothing fancy here. I've enabled DPD. Okay, I've saved it. So now you will have to add the phase 2. Phase 2 is fairly simple. Mode IPv4, address 14.140.40.109. Whatever is the protected IP pair, you can put that here. And then the remote IP. So these are the communication I want the communication between these two IPs to be secured over IPsec, which in terms of Juniper, you call it as proxy ID, and you can call it as traffic selector or encryption domain as well. So these are my encryption domain. Phase 2 proposal, it's fairly simple. ESP AES 28-bit, AES 128 GCM mode 128-bit, and PFS also is there with 14 group 14. Lifetime is 3600. Save this configuration. Do the same thing here. Under VPN IPsec, I have already done the same thing here. There is no difference. So this was the certificate that was generated for this PfSense Firewall 2, and I have exported the same CA which was used for signing this PfSense certificate. Rest of the thing is very similar to the Firewall 1. And then you have phase 2. It is similar to phase 1. The encryption domains are listed in reverse manner. You can see here. Okay, so now we'll come to the certificate part. Okay, so if you click on, okay, first of all, let's complete the VPN configuration. Once you are done with the VPN configuration, you will have to create the rule under IPsec. So I have created the rule as well. You can see here. Okay, it is fairly simple. Source, destination, allow. And then here also, it's fairly simple. Under IPsec, I've created the rule to allow the traffic. And then now comes the main part here. So in cert manager here under system, you will have a tab for CA cert, you will have a tab for certificate. So here in my scenario, the CA cert, the CA certificate authority is an external entity. So what I have done is I have exported the information of my CA here in this particular tab. So how to do that? Well, if you want to know how you can generate a certificate and how you can sign a certificate, then you can follow my previous video on OpenSSL about how to generate a certificate and how to sign a certificate. Well, in this video, I'm going to show you how I have done that. So this is my cloud VM. So the first command that you're going to use here is the generation of key. And mind you, the encrypted key will not be accepted here on PfSense, which means you will have to export the key directly here. If you have encrypted the key, then you will have to decrypt the key and then copy the content and then paste it here. There is no option of decrypting the key. So that is the reason why, if you see here, I have not used any encryption algorithm to, protect my key. So this is the command to generate the key, and this is the command to, generate the certificate from the RSA key that you have created. And in order to sign a certificate, well, okay. So this is the command that you can use for signing a cert. So you can see here I'm using my CA cert as an input along with CA key to sign a cert with name, and output is going to be P12 PKCS 12. This is just an example. You can put whatever information that you want, either a PAM, CRT, or PKCS. So since I already have the certificate, the CA cert here in my machine, so I can show you that. So this is my CA cert. So in order to get the content, you'll have to right click and then open with Notepad. Okay, and you will have to copy the entire content here in this field. Once you are done, then you will have to copy the content of the private key, and you will have to keep it very private, because once this thing is compromised, then anyone can crack into your communication. And then, okay. So once you're done, you will have to export the keys as well. So you will have to copy the content of the key as well here in this field. This is a scenario where you have an external CA. Okay, and I'm going to show you how you can generate the CA here in the firewall itself. So this is the scenario where you have an external C. Rest of the thing you can put it as similar, and then you will have to click on certificate. So what I did here in this scenario was, I clicked on this option and I created a certificate signing request. Okay, and I filled in all the information. And once it was done, for example, let me try to generate a test certificate signing request. So once you do that, you will get the certificate listed here, which is the certificate signing request. It is not signed by anyone. And then you can export this, or you can copy this, I guess. Okay, you can export this information. So you can copy this information, and then so you can save this request. You can see here the file is .req, which is certificate signing request. And then you can go ahead and sign this certificate and then upload it back to the portal here, like how I have done here for both the certificate. And since both the certificate signing request was actually both these requests were generated from this particular firewall, so that is the reason why you see the certificate listed here. Okay, so once you sign the certificate, you can copy paste the public and the you can once you have the certificate, you can copy the content here, similar to the certificate authority. What you have done here, click on certificate, click on this, click on import an existing certificate and then name it and copy the same thing here. For example, you can see here, if I right click, do the open with notepad, I can copy this content and I can paste it here. And again, the private key as well. So if the certificate is external, then you can copy paste the certificate data and the private key here. And since the data was generated on this firewall, so in order to get the information, you can click here and then copy the content. So once you have the CA updated here, you will have to click on certificate, generate a certificate signing request. Either you can do it individually on both the firewall, or you can, generate a certificate and then sign it and then upload it here. Since I have generated both the certificate from this firewall, signing request, so that is the reason why you see both of them listed here. But then if you want to copy the content of, let's say, if this is a certificate that is going to be used on this firewall, so what you can do here is you can click on edit and then copy this content here, like how I have done. So I have, copy pasted the content from here to this field and then private key here to this field. And once I do that, I am ready to use this certificate, and the certificate will show the information as well that it is signed by a CA, which is this certificate, and I have the certificate, this one as well here. So my firewall is going to trust this certificate. Okay, once you are done with this, then you can go to your VPN and then under authentication, you can select that certificate. And then you will have to select the CA cert as well, which was used for signing the certificate. And then the same thing here you can do. Once you are done, then we can try to establish the VPN. Or let me show you the other way around, where you want to initiate the certificate generation from the firewall itself. So if you are willing to create a certificate authority on the firewall itself, then you can do this. For example, I'm creating a CA test. So you can see here, I have created a CA test certificate authority. This is my public key. Okay, my public key will be inside this data. Basically, it gives you all the information about the certificate. And this is the private key, which is very confidential. So once you have this certificate, then you can create a certificate here. And then you can select which certificate authority should sign your certificate. So you can select here, test one. And then you can fill in all the information. And then you can click on save. So one more thing you'll have to keep it in your mind is in the common name, you will have to keep the firewall host name. For example, this firewall host name is PfSense -01. So you'll have to copy paste the content here. And then in FQDN part, you can put the IP address. Okay. And I'll show you the content as well here. So if you see the already existing certificate that was generated externally, you will see that the subject alternate name is IP address and the DNS name is PfSense02, which is the common name. And if you see this certificate again, you can see the common name is PfSense01, here PfSense02. So the common name, make sure you put the host name of the firewall, and then in the SAN entry, you can put the IP address, the peer IP. So once you are done, it'll show up as test firewall 1 signed by CA cert, and you can go ahead and use this cert in your configuration. You can see here. So this is how you can do it on your firewall itself if you don't have any external certificate authority. But make sure you have the common certificate authority updated on both the firewall in order to have the firewall trust that certificate. For example, here in this example, the CA cert is CA, and this is the certificate. This is the certificate server certificate authority certificate that is used for signing the uh, server certificate. So what I've done is I have generated the external one, since if you're using this, if you're trying to generate the certificate on the firewall itself, then you will have to copy this content and then paste it here so that this guy knows that who has signed this certificate during the exchange. So once this is done, then we can try to bring up the IPsec. And if you want to see the logs, well, you can see it. So you can see the logs here in the IPsec.log. So let me try to bring up the, so this is the 109 end. So I'm going to bring up the connection. So you can see here established, and in the logs also you can see what is going on. Main mode, proposal, you can see here receive proposal. pseudo random function. You can see here ISACAM cert. So they are going to use RSA. You can see here this end sending the certificate request. Whoever is initiating, the information that he received. So this is PfSense. Okay. So here you can see here the other end is presenting the certificate PfSense 02, canonical name 02, like I said. It is signed by Sumit.com. You can see here. Okay, this is the email ID. Okay. This is the issuer information. So you can compare this information with this. It is going to be the same. Canonical name Sumit.com. So this was a certificate that was used for signing the certificate with canonical name 02. So you can see here using the trusted CA cert, checking the certificate status of this. Authentication of 129 with RSA, EMSA successful. So till here is the phase 1. After that you can see the firewall is initiating quick mode, which is phase 2. And in the first packet it is sending the identification payload again, which is having the information about the protected pair. You can see here. And then that's it. So that's all in this video. I know it's a little confusing, but then it's fairly simple if you have a little knowledge about the generation of the certificate and how to use it in your environment. If you have any questions, do leave them in the comment section so that I can answer your query. And by the way, the method that I used for the IPsec configuration was, you know, uh, generating the external CA cert and then creating a certificate and then signing it and then uploading it here. So what you can do is, for simplicity, you can do it from the firewall itself, the steps using the steps that I've explained you in this tutorial. So please go through it. If you have any question, do let me know. And that's all in this video. Have a good day. Bye-bye.